In this video, we're going to look at wave characteristics. First, let's talk about what is meant by the term wave. A wave is a rhythmic disturbance created by an oscillating source. Well, what does oscillating source mean? An oscillating source is simply a source that creates an oscillation. Then what is an oscillation? Well, look at this picture and see if you can figure out what an oscillation is. An oscillation is just a vibration or back and forth motion. That means that a wave is a rhythmic back and forth motion. So let's look at some wave characteristics. You should have a copy of this diagram. We're going to label this diagram and talk about what each of these things means. A is what we call rest position. It can also be called equilibrium. And this is exactly what it says it is. It is the position of the wave if it is at rest. If the medium is at rest, then this is where it is. Now let's look at B. B is a crest. A crest is the highest part of a wave. So there, this is also a crest. This is also a crest. Conversely, down here at G, the lowest part of the wave is called the trough, and that would be here. This is also a trough. This is also a trough. Moving on to C. C is the wavelength. It indicates to us the length of the wave. Wavelength is the distance between two adjacent crests or troughs. So this distance from here to here is a wavelength, as is this distance from trough to trough is also a wavelength. The wavelength can also be viewed as the distance from where the oscillation begins to repeat itself. So technically the distance from here to here, where the pattern begins to then repeat, this distance is also a wavelength. Next, let's look at amplitude. Amplitude is the distance a wave rises or falls from the equilibrium position. In this picture, that is indicated by E. This would be an amplitude, as is F. F is also an amplitude. This would be an amplitude, this would be an amplitude, and so on. Now let's look at a couple of wave characteristics that don't appear on our diagram. The first of these would be period. Period is the amount of time that it takes to complete one cycle or oscillation. So basically it's how long it takes for one complete wave, one complete cycle, one complete oscillation to pass by a specific point. Since period is the amount of time that it takes for this to happen, it is measured in seconds. Very similar to period is frequency. Frequency is the number of wave cycles that pass a given point in 1 second. Notice in the diagram, waves that have a high frequency are very close together. You're going to get more waves passing this point in 1 second if the wave is moving in this direction. The low frequency wave, if we were to look at the same point, the wave still moving this direction, it's going to take much longer period of time for one complete wave oscillation to pass that point. The units for frequency are waves per second. Now, the idea of number of waves, that doesn't really have a lot of meaning. That type of unit is just a number. So it's not like it's meters or grams or anything like that. It's just a pure number. It's not a real unit. So another way to write this is just 1 over seconds. Well, 1 over second is a hertz, and that's abbreviated Hz. And so this is the unit that we use for frequency. And hertz is the unit that is used for frequency of many different things, not just waves. I mentioned that period and frequency are very similar. Let's examine the relationship between the two. Period is measured in seconds, and frequency was measured in hertz, which is 1 over seconds. So by looking at the units for each of these quantities, we can see that they are extremely similar. Frequency is the reciprocal of the period, and that can be written as such, where capital T stands for period. Okay, and since frequency is the reciprocal of the period is the reciprocal of the frequency. It works both ways. So keep these two relationships in mind. You will need those later. We now know enough about the characteristics of waves to be able to find wave speed. Wave speed is found using this equation, V meaning speed, and of course that's measured in meters per second. F stands for frequency. We've already established that that's measured in hertz. And lambda, which is a Greek letter, stands for wavelength. And since it is a length of a wave, it is measured in meters. So the equation we will be using for wave speed is V equals F lambda, or you may see it written V equals lambda F. Doesn't really matter which way it's written. Multiplication is a commutative property, so it doesn't matter what order we multiply in. This will be our equation that we use. It is very important that you keep in mind what these units have to be. If anything is not in a standard unit, you will have to change it to a standard unit. Now, of course, you know if I give you an equation to use, you're going to have to actually do some calculation. So let's do one practice together. So let's do this one. Water waves in a lake have a wavelength of 2.9 meters and a speed of 2.4 meters per second. What is the frequency of the waves? Well, the wavelength is 2.9 meters. The speed is 2.4 meters per second. And I want to know the frequency. We use our wave equation. V equals lambda F, or V equals F lambda. V is 2.4 meters per second. The wavelength was 2.9 meters, and we need to find the frequency. Okay, plug that in your calculator, do a little algebra, work your magic, and the frequency comes out to 0.83 hertz. Now I want to know what is the period of the waves. Well, period is going to be the reciprocal of the frequency. So take your answer from above and find the period. It should be 1.2 seconds. Ta-da! Piece of cake!